Hello. We're Team One, and my name is Tommy Singyup Lee, and my teammate's name is Cherry Zhang. And we're here to present our case study on the bankruptcy data. And we're working with a total number of 120 observations for this particular project. So, just a brief introduction before we begin. The primary focus of this business case is to predict corporate bankruptcy. And then in this case study, we're going to analyze some of the important factors that are being used to predict bankruptcy. And our data contains a total of 24 financial ratios for each firm in the data set. And then a number of bankrupt firms are chosen. And for each of the failed firms, a healthy firm of similar size has been selected as a comparison. And these ratios will provide a comprehensive understanding of these firms, and the ratios use a numerous amount of variables, such as but not limited to current assets, total assets, current debt, etc. So moving on to the description of the data sample. Like I said, we're working with a total number of 120 variables. And we deleted the first and the third columns, which are the observation number and year for simplicity. Y1 is equal to cash over current debt ratio, and Y2 is a categorical variable indicating a bankrupt firm when it's equal to 1. For Y1, we have selected several variables. The variables that are selected are as follows. R2, which is equal to cash over sales. R3, cash over assets. R4, cash over debts. R7, cash flow from operations over debts. R9, current assets over current debt. R12, current debt over debts. R15, income over debts. And R21, assets over debts. We also explored the correlation among the different variables, and based on the correlation metrics we got, there are no variables that are correlated with a correlation greater than 0.9. So no variables are further excluded from the selection above.
So for the variables related to Y2, it's based on the correlation matrix. So there are some overlaps with the variables with Y1, but not a lot. So the first one is R4, cash over debts. R7, cash flow from operation over debts. R9, current assets over current debt. R12, current debt over debts. R15, income over debts. R18, income plus depreciation over total debts. R19, sales over receivables. R21, assets over debt. And R24, which is working capital from operations over debts. The variables selected are not different versions of one another or complementary.
So moving on to partitioning the data into 60% training and validation, 40%. It has been done separately for data 1 and data 2, or simply saying we have partitioned the data specifically for Y1 analysis and Y2 analysis. Moving on to the analysis of Y1 outcome that excludes Y2 from the analysis. We have created a CART model with the parameters as follows. The minimum size of the end node is 1, with maximum levels for tree equal to 4, and the complexity parameter equal to 0.0001. Based on this regression tree, there are a total of 8 end nodes, and the variables that are selected in the tree are R2, R3, R4, and R9. In terms of the interpretation of 4 of the end nodes, the highest average end node is equal to 4.9, and the path is as follows. It's equivalent to the firms with R2 greater than or equal to 0.64, and they have Y1 equal to 4.9. The second highest average is 1.8, and these are the firms with R2 less than 0.64 and R3 greater than or equal to 0.46. The lowest average is equal to 0.081, with firms with R2 less than 0.64 and R4 less than 0.21 and R3 less than 0.045. The second lowest average is equal to 0.22, and these are the firms with R2 less than 0.64, R4 less than 0.21, and R3 greater than or equal to 0.045. Moving on to the variable importance measure. Turns out that R2, R3, and R4 tend to be the most important variables, followed by R9, R20, R12, R15, and R7. And the four variables of importance are included in the regression tree above. In terms of RMSE, it's equal to approximately 0.697, which is about 242% of the mean, which is equal to 0.288, where the mean is equal to the mean of y1 from the original data. And we believe that this figure is relatively very high. So overall, this model yields a very high RMSE compared to its mean. Moving on to the random forest model, we've created such model with the parameters as follows, attached in the screenshot. And in terms of the variable importance, the first three models follow the same order as a cart model, and the other four are rather mixed. So it's followed by R7, R9, R12, R15, and R21. And it's really interesting to note the importance of R7, the least important variable of cart model, has become the fourth most important variable under the random forest model. The RMSE in this case is equal to 0.208, and this is approximately 72.222% of the mean of Y1. And although this is a huge improvement from the cart model, the RMSE is still too large relative to its mean. Moving on to the last model, which is the neural net model. We've created our model based on the parameters provided right here. And this is simply showing the plot of the neural net model. And in terms of the variable importance, R20, R9, and R2 are the most important variables. So the order of importance differs greatly from those of cart and random forest models. And in this case, the RMSE is equal to 0.267, which is approximately 92.775% of the mean of Y1. And although this is less than RMSE of cart model, it's slightly greater than the RMSE of the random forest model. And once again, the RMSE is still large relative to its mean. So overall, when we're comparing the RMSE from the models 1, 2, 3, it's the random forest model that yields the lowest RMSE, although relative to the mean of Y1 from the original data, the error is still too high to be a good model.
So moving on to the analysis of Y2, first of all, we use the cart model. And here's the plot. We can see that the selected variables are R24, R9, R21, and R18. So looking at the endnotes, we can see that there are actually 3 endnotes with 0% proportion, and we'll only choose 2 to answer this question. So the first one, the highest proportion endnode is actually 100%. So it's this one. The path is one out of one firm, with R24 larger than 0.095, R21 larger than 1.6, and then R18 smaller than 0.18 did not go bankrupt. The second highest proportion endnode with a proportion of 96.8%, it's this one. And then for the smallest proportion endnode, there are actually 3 endnodes with 0%, which is this one, and then this one. So moving on to the variable importance measures, we can see that R18 has the largest variable importance, followed by R24, R15, and R21. R7, R4, and R9 are relatively not that important compared to other variables, especially R9, with only 4.3 variable importance. Next, we plot the ROC and we computed the area under the curve about 0.8. So next we generate the confusion matrix, and we can see that the accuracy of this model is about 0.81, and then the sensitivity is about 0.9. So it's not a bad model, it's fairly good. So moving on to the next model, we have the random forest. And we can see after computing, we see that R24 and R18 still have the highest variable importance, same as the CART model, followed by R15, R9, and R21. Others have relatively low importance. And here's a plot for the variable importance measure. We also compute the ROC and the area under the curve. For the random forest, we can see the area under the curve is actually very high, it's 0.88. Next, we also generate the confusion matrix. And this time we can see the accuracy is 0.79, which is lower. The sensitivity is 0.85, which is also lower than the CART model. Lastly, we'll have the neural net model. Here's a plot using the same variables. The variable importance measure is here. We can see that R18 and R15 still has the highest variable importance, same as the previous models, and then also R24. And the area under the curve for this model is 0.83, which is also not bad. So it's a good model overall. And then looking at the confusion matrix, we can see that the accuracy is 0.75, which is the lowest among the models, and the sensitivity of 0.82. So comparing the area under the curve, we can see that model 5 has the highest area under the curve of 0.88, and the lowest one is actually the first CART model with only 0.8.
So in terms of the model selection, for Y1, random forest yields the lowest RMSE of 0.208, which is equivalent to approximately 72.222% of the mean of Y1 from the original data. And with the other two models yielding higher RMSE, the random forest model is indeed the best one. However, it must be noted that the RMSE is still extremely high compared to the mean of Y1. Thus, overall, all the three models provide a poor fit.
So for the Y2 outcome, the CART model, although not having the highest area under the curve, it does have the highest prediction accuracy in the confusion matrix of around 82%. And also the CART model has the advantage of being visually clear. So that will be all for our presentation.